So the ground itself curved down. So what happens is, think about if you have some curved from here. So this you will still drop, but drop it here. Okay, it will land it here, right? This one will land it here. And if you have some, okay, for some large enough velocity, the curvature of this cannonball will be the same as the curvature of the Earth. Okay, in that case, okay, the cannon, okay, the ball will hit the cannon back. Yes, that's true. So that's how Newton unified the projectile motion and the circular motion. Starts with the projectile motion. If you keep increasing the initial velocity, finally you can form some circular motion. Okay, because our Earth is circle, is a circular, is a sphere, so you don't have a flat ground. So it's possible that you have this. Okay, in other words, even though the cannonball is falling down, but the ground is also falling down. So it's possible that they are falling down with the same rate, so they never touch each other. Okay. So that's it's called Newton's cannonball. Okay. He used this kind of thought experiment to demonstrate that the apple will fall down on the ground because it doesn't have any initial velocity. The cannonball will fall down on the ground because it doesn't have enough initial velocity. And the Earth can move around, or the moon can move around the Earth because somehow it has enough initial velocity, so it can move around the Earth forever. Okay, so this is the circular motion. And here the graph shows that if you have some, say, cannonball, of course, none of the cannonball can have this large velocity, but rocket can have this large initial velocity. So that's why we can make man-made satellites and send them to move around the Earth. Okay. So here what happens, if you look at the graph here, is with small initial velocity, it will still fall down on the ground, but with some large velocity, okay, it will form some circular orbit. If you even increase the velocity, okay, it will form some oval, okay, ellipse motion, okay, and so, but it's still moving around the Earth. And what happens if you keep increasing the initial velocity? Finally, so what happens is, okay, with some velocity, you can have the circular motion. And then you have motion like this.